Okay, for sort of an upcoming project. Really, this is a side thing that goes with other projects. I just threw together a little environment monitor, nothing too fancy. DHT11 and BPM 180, photoresistor, checking the local environment, temperature, humidity, pressure, lighting, and that way other things can tie in and adjust fans and lights around the house, or just some general data collection on weather. Used one of the knockoff nanos. Uh, Ordered a whole bunch of those recently, so I don't mind just burning them up in a project. And OLED screens. Again, I ordered a whole bunch of them from one of the Chinese wholesalers. They're all about the same. But once I saw it on the digital display, I was like, oh, I'm not very happy with that display. I want something that looks, I want something that looks different than that. I'm not quite sure what I want, so I'm going to try a couple different ones, but there's still a whole lot of pins on the microcontroller not being used. And well, I remember way back in the early 80s when I was a kid, digital displays were so fascinating because it was new and interesting. And now I'm like, digital display just seems run of the mill. I want something fancy and neat looking. So I still got a bunch of pins on the Nano here, so I'm gonna try to put together some more interesting displays and see what I can come up with for this. So my main two thoughts on what might make an interesting display is something, I guess, kind of going back to the traditional displays for environmental data. Um, Maybe some little things that wave back and forth. Right? Hook up a couple little servos and have a meter spin it back and forth, look like a meter. So I'm gonna throw that together. And the other idea, the one that I think I'm a little happier with, once that I think will look really neat, is I've got this almost quarter-inch sheet of acrylic. So I was thinking maybe get some LED, stick some LEDs in here, and take one of the hobby knives and do a small um, scratch light, the scratch lighting thing. I'm not sure what the technical term for it is. Where like the LED goes down at the corner, and then there are a bunch of perpendicular scratches, so that depending on the brightness of the LED, it'll turn on different number of scratches. So I'm trying to put those together, make some little clips, and see how that goes, and see if that looks good. Because yeah, digital displays have been around long enough now that even with a nice OLED screen, I'm kind of like, the digital display seems run of the mill. I want something, I want something fancier since I have so many pins left on the Nano after the sensors it takes to measure the environment. Okay, so there's nothing fancy going on in the code here. It's a stereotypical example of environment monitors. So libraries for the DHT11 and BMP180, I2C, which is just running the OLED screen, and then the library I like for the OLED screen. Set up some objects. The photo resistor is just in a voltage divider, just doing that directly. The setup is mostly just dot begin stuff and set that voltage divider as an input. Then down here, grab the humidity and temperature from the DHT11, which at one point I thought maybe an average of those two, because both of the pressure and the humidity sensor can grab the temperature. But the difference was 6 or 7 decimal places over, well past what's going to be truncated. So they were both given the same temperature. So I just grabbed it from the humidity sensor. The pressure, throw that stuff uh, on the OLED screen, and both its percentage, like humidity is percentage, and the absolute one, which I wrote a method to convert that. Display the pressure, get the lumens, which is this calculation down here. So value is the analog read from the photoresistor based voltage divider. Turn that into a voltage. The difference between that voltage and the actual voltage tells what resistance we have. and then there's 500 lumens per milliohm for conversion factor. And that gives the brightness of the room in the standard metric units for lighting. And then throwing back all that back on the OLED screen, which I'm not happy with the OLED screen. I've got a bunch of pins left. I want to do something fancy. Oh, and then here's the calculation to get the absolute humidity. I did have to look that up. That was a mess to turn, and that was a mess to kind of put together, but you can see the formula there. I'll leave it there on the screen for a second, so in case you need to copy it. But that gives grams per cubic meter, the actual measurement of humidity in the air rather than the one that weathermen always tell us. So let's get back to trying to get some outputs together, and then we'll look at the code for the adjustments on that, which is really going to be PWM to either a light LED for the side light signs or PWM to a servo motor for the swaying needles back and forth, which I almost never use the servo libraries. I just do the PWM directly for that. It's really easy. So let's put some devices together, and then we'll come back and adjust the code to fit those. Okay, so first step is I cut that sheet down into several pieces and got some extra, so I get more than one try at this. I've found over the years that's important. And I cut a little groove here so you can see that without any scratch, when it's a nice smooth surface, we can't really see it anywhere. The light goes right to the edge, so if we add some scratches in here, we should be able to see the light showing up there. So I put this together, and I'll just kind of make the first little mark here. That part's going to be covered, so that once there's a scratch, then that scratch kind of shows up on the LED. Kind of see it. Oh yeah, if I move it up. Yeah, so the scratches tend to show it. So then I'm going to try using PWM to represent that signal. So I'll get the design marked up here and a bunch of scratches cut in here, and be back shortly after the video editing to see if this works as intended. Okay, so just got up to the first indication that this might work. There's still a lot of refinement, but if I try to get some shade there, you can see the scratches are showing the red and green separately, and it's kind of hard to show up on the video, but the green's coming up to about this scratch with the PWM it's currently set at, and the red somewhere over here. So the first indication that this might work, but there's still a lot of refinement to go. And so here it is up at the first, I guess, proof of concept section. So you can see the red, the green, the blue, and the yellow are all kind of distinguished. I'm shooting this on the phone, so obviously there's a bit of the automatic adjustment thing for lighting that the phone has. It'll look a lot better at nighttime, I think. But it looks like it's going to work, so now I'm ready to control those signals from the environmental monitor and see what this looks like. Oh, and I was apparently out of black electrical tape. I might need to pick up some black electrical tape or something, or find some sort of case that the LEDs aren't going to shine through at the bottom there. Okay, and here it is showing the current environment conditions, which seems reasonable. So late July, a storm just passed through, so a cool day for July, but we can see the red's kind of coming up to about here. And the storm just passed through, so our air pressure is way down here, kind of one green bar showing there. And, well, pop-up thunderstorms, so the humidity's, you can see the humidity is way up on the chart, and the clouds haven't left yet, so there's just a little bit of yellow showing down here for the lighting. So it seems to be working accurate. I guess more of a proof of concept than anything else, because now I'm thinking the servo, having a little servo motor swing a needle back and forth to a gauge is going to be a lot easier to interpret. But As far as a proof of concept that this sort of output does work accurately, it'll work for that, and maybe I'll come up with another project where this sort of output can work later. And yeah, I'll try to take another video of this at nighttime, and hopefully it'll come through better without the camera doing the automatic adjusting for light and stuff like that. But it seems to work, so let's take a quick look at the code here. That seems about accurate for a late July day where a pop-up thunderstorm has just rolled through. Very low pressure, a whole lot of humidity, and the day kind of cooled off. And the clouds haven't left yet, so there's almost no light. So it seems to be working, but really just a proof of concept. I don't think I'm going to use that for environmental monitoring now that I see it, but I know it works for output. So let's take a quick look at the code running this and finish this video. And maybe I'll try to get some shots of this at night to see if it comes through better, but I have a feeling the camera will still adjust for the lighting then. Okay, and so here's the code for the result there. Bring in the libraries for the sensors, set up the objects, and the OLED screen was replaced with just some LEDs. Set those up as outputs, and most of the sensors are reading in floating point numbers, so those need converted to integers. For the pressure reading, this constant multiplier right here turns that into a reading of inches of mercury. So that's the air pressure I'm most used to hearing about here in America, but there's the similar concept. So for whichever way we want to output that pressure reading, and just set that as an integer. So then I map for the analog write, I just mapped reasonable ranges. So like temperature from 32 to 100, obviously that's in Fahrenheit. 32 to 100 degrees maps from 0 to 40 on the PWM signal. Same thing for pressure, which I did it in inches of mercury, another American unit. People, the rest of the world, might want to use a different constant to get the standard metric system. And just map that to something that looked good on that LED in the particular side lit sign. Same thing for humidity reading and the lighting, which I used a flashlight and some shadows to find the number of lumens to expect, which mostly fall in that range, and then map that to something that fit the yellow LED. And then those formulas for adjusting, converting things. So convert the analog read into a resistance, and then the resistance converts directly to a number of lumens. Or, well, I left the method in here. The messy looking equation to get an absolute humidity reading, which will be grams per cubic meter out of the humidity sensor, but not the one that was used here. So basically the same thing, just a different output. And I guess it worked as a proof of concept that side-lit signage works with PWM output from a microcontroller, though I think I'm going to go with a different sort of output for the environmental data. Okay, and here's the other design. I think I like this one a little bit better, but I probably should have double-checked my materials, because the most I had of any size servo was 3. I have a bunch of sizes of servos, but for something like this, they kind of need to all go together. And then I decided to put the gauge meters on the backlight thing. So I just did one and used an RGB LED to get the same things. So red is temperature, green is pressure, blue is the humidity, and yellow is the lighting. And I finally found another use for the MacBook than just creating installers when I make a cross-platform piece of software. It works pretty good for some shading here. But I think that output looks a little bit better once this is blocked, so I'm not seeing that so much. And get that side lit signage for the gauge. and then servos showing those meters. But I only had one, so I had to do something to finish the video, but I think that'll make a really nice looking output for environmental data. And let's look at the code of this and finish up the video here. Alright, so here's the adjustments to the code. I did go ahead and use the Servo library for the purposes of the video here. I suppose most people use that. It's easy. Controlling the servo is not hard though. Set a PWM frequency of 50 Hertz and then a duty cycle between 5 and 10%. 5% is the 0 degrees and 10% is 180 degrees. So it's not a whole lot to, that library is not covering anything complicated, but I went ahead and used it for the video. And just set up that, and then the pins for the RGB LED. Some straightforward setup, and then take the temperature reading, kind of the same mapping from 32 to 100 degrees, which is in Fahrenheit, obviously not Celsius temperature, and map that to 0 to 180 degrees. Same thing on the ranges that were shown earlier, mapped 0 to 180 on the servo. Oh, the lighting went 180 to 0, so reverse the lighting, but the same ranges, just map to the servo and then flash either yellow, blue, where's the other ones? Yellow, blue, green, or red, depending on what it's showing. So the code should be fairly straightforward. I'm going to have to order some more servos to finish that up, but I think that'll make a nice looking output for that environmental data. And that'll sit in the window somewhere where it can still kind of see through it and just have the little gauges moving back and forth on some side lit signage so that it kind of glows and has gauges moving. And I think it'll look nice. Digital, I'm starting to feel like digital outputs feel so run of the mill. I'll do something fancier whenever there's pins available. But just thought I'd share this video, so hopefully soon I'll be able to get some more servos and actually do 4 different gauges, but for now the one will work.